Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve a trigonometry model word problem. As per the problem, at high tide, water reaches 5 feet mark on a retaining wall. At low tide, the water reaches the 1 foot mark. Assume that high tide occurs at 12 noon and midnight and that low tide occurs at 6 p.m. and 6 a.m. Determine the first time after 6 a.m. that the tide will reach the 4 feet mark. Assume that t equals 0 is at 12 noon. So we have to find the time at which the water level will reach 4 feet mark after 6 a.m. In order to determine the first time after 6 a.m. that the tide will reach 4 feet mark, we need an equation for the height of the water at any time t. So first we'll have to find the equation for height in terms of time t. To find the equation, we should sketch the given information. Let's assume the variable for the height is h. So h goes on the vertical axis and t for time goes on the horizontal axis. As per the problem, t equals 0 represents 12 noon. As per the problem, the maximum height of the water is 5 feet and the minimum height is 1 foot. As per the problem, the high tide occurs at 12 noon. Therefore, the maximum point on this graph lies on the vertical axis. The next high tide occurs at midnight, which is 12 hours away from 12 noon. Therefore, the period of this function is 12. And as per the problem, at midnight, the height of the water is 5 feet, the maximum value. And as per the problem, the low tide occurs at 6 p.m. 6 p.m. is the midpoint of 12 noon and midnight. And at this time, the height of the water is 1 foot. This is the minimum point on the curve. We can sketch one full cycle for this graph by joining these points. This is one full cycle for the problem. We can use this sketch to write the equation of the function. So we know that the maximum value is 5, the minimum value is 1, and we know the period of the function is 12. We can use the maximum and minimum values to find the amplitude and vertical translation or midline for this graph. Let's start with the amplitude. The formula for amplitude is max value minus minimum value divided by 2. I get 2. Next, we can find the vertical translation or the midline for this graph. As you may know, the midline of this graph is a horizontal line that passes through the middle of the graph. Since it's a horizontal line, we write its equation as y equals a number. The formula for midline is maximum value plus minimum value divided by 2. The equation of midline is y equals 3. Now we can write an equation for the graph. As we can see in the graph, the maximum point lies on the vertical axis. That means we can use cosine function to write an equation for this graph. The general equation of a transform cosine function with variables h and t is h at t equals a times cos and then k times t minus d plus c. In this equation, a, k, d and c are transformation constants. We have to find the values of these constants. Different teachers use different letters for these constants. The resulting transformations are the same. Let's start with the a value. In this case, there is no reflection over the x-axis. We are using the cos function because the maximum point is on the vertical axis. So the a value is equal to the amplitude, which is 2. For k, we can use the formula 2 pi over period. We use 2 pi because that's the period of the parent cosine function. As per the graph, the period is 12. We can reduce this fraction to pi over 6. This is the value of k. Next, we can find the value of d. As you may know, d represents phase shift. Since the maximum point on this graph lies on the vertical axis and we are using the cos function, the phase shift is equal to 0. And the c value is equal to the value we got for the midline, 3. So the equation for this graph is h at t equals 2 cosine pi over 6 t minus 0 plus 3. T minus 0 is just t. So we get 2 cos pi over 6t plus 3. Now we can use this equation to find the time at which the height is 4 feet after 6 a.m. In order to find this time, let's first understand when the time 6 a.m. will occur using the sketch I drew on the board. Time 6 a.m. is 6 hours ahead of 12 midnight. So that means 6 a.m. is 18 hours away from 12 noon. And after another 6 hours, which is 24 hours from the starting time, it will be 12 noon again. We can use this information to draw the second cycle for this graph. We have to find the time when the height reaches 4 feet after 6 a.m. So that will be somewhere here on this graph. So that occurs in the second cycle in this graph. In order to find the time, we should sub in the height as 4 feet. In our equation, we should replace h with 4 on the left side of the equation. We have to isolate t in this equation. The first step is to subtract 3 from both sides. 4 minus 3 is 1. Next, we can divide both sides by 2. I get cos pi over 6t equals 1 over 2. I get a positive value for cos term. As per the CAST rule or the ASTC rule, cos is positive in quadrants 1 and 4. As per the unit circle or the special triangle for angle pi over 3, cos pi over 3 is equal to 1 over 2. So the solution in the first quadrant is pi over 3. So our first equation is pi over 6 times t is equal to pi over 3. This is the solution in quadrant 1. In quadrant 4, the solution is pi over 6t equals 2 pi minus pi over 3. This is the solution in quadrant 4. We should solve for t in these equations. In the first equation, we should divide both sides by pi over 6. We can simplify the expression by writing it as a division statement. Next, we can change it into a multiplication statement by flipping the fraction pi over 6 to 6 over pi. We can simplify this expression. The pi's cancel each other out and we can reduce 6 and 3. I get t equals 2 hours. Next, we can solve the second equation. 2 pi minus pi over 3 is equal to 5 pi over 3. The denominator of 2 pi is 1. The common denominator is 3. That's how we get 5 pi over 3. Next, we can divide both sides by pi over 6. Five pi over 3 divided by pi over 6 is equal to 10. So the second solution we get is 10 hours. So the two solutions we got, 2 hours and 10 hours, are here and here. As per this sketch, the first time that the tide will reach 4 feet mark after 6 a.m. should be between 18 and 24. We can get that value by adding the period to the solution we got in quadrant 4, which is 10 hours, because the period of this function is 12. So the answer is t equals 10 plus 12, which is equal to 22 hours. Since we are given the clock times at which the high tide and low tide occurs, we should calculate what time will be 22 hours from t equals 0, which is 12 noon. It will be 10 a.m. because 24 hours is full day, that will be 12 noon. So 2 hours before 12 noon is 10 a.m. So the final answer should be 10 a.m. That means after 6 a.m., the first time the tide will reach the 4 feet mark at 10 a.m. from the starting time. This should be the final answer for this problem. So these are the steps you have to keep in mind to solve this problem. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.